Hello, my name is Syed Mashuk. I was invited to do this video for my next stage for the graduate scheme of the N-Power Engineering. So today I'll talk about N-Power as a forefront runner of the energy sector. What sort of factors will turn into it in the future, next 20 years? What sort of issues it's gonna get and how to get ahead with them, and how do I fit in as an engineer in those areas. So to start with, I have recognized there is five crucial factors that will be happening in the next 10-20 years which will guide energy investment in N-Power, which will be global decarbonization drive, a shift towards decentralization, disruptive innovation and technological advancement, relentless focus on efficiency, and the last one is the rise of an ever more interconnected world. To start with, global decarbonization drive. That is, obviously we want to have use as little carbon as we want, and to that extent, in 2015 December, there was a contract signed as COP21 in Paris between one nation countries. But obviously, we know that US is trying to pull out of this now. But the recent finding from the scientists that shows that we in fact need this agreement to go on, and to that extent, the way it's gonna work, it has to be collaborative agreement between all those countries. To that extent, fossil fuels at the moment continues to be the cheapest energy source, and they will remain a large proportion of the world's energy system. Natural gas will be the biggest winner, with consumption globally rising by 50% by 2040 as the world shifts away from coal. So now, my PhD topic is about reducing emissions, in fact mainly NO and CO, from the atmosphere, from mainly using fossil fuels. So I use laser diagnostics to look at the combustion emission that's coming as like a soot, NO, CO, and how can we reduce them? How are they being formed, and how can we reduce them and how can we make the future design of the combustion even more efficient and less pollution? So the next topic is the movement toward decentralization. Within the power and utility sector, the trend for installing smaller generation plants will continue on the growing economies of scale, combined with government subsidies, supports the rollout of greener technologies. The rate at which costs are coming down for these technologies will further support their growth onshore wind cost, which may be falling by 41%, and solar PV costs predicted to fail by 60% by 2040. So this is leading to prediction that in the UK, up to 14% of the capacity will be on the distribution network by 2030, compared to just 16% now. So this data is telling us that we're gonna move towards decentralization. We're gonna move towards more cleaner energy, more renewable energy. So we may be looking at having hydrogen as a fuel in the future. So that's why in my PhD I'm also working on hydrogen fuels at the same time. So to go to the next topic is continued innovation and technological advancement. New development are unlocking potential right across the energy sector, creating opportunities for those who can adapt and scale fast. That said, it is important to bear in mind that innovation does not necessarily come from new technology. In many cases, it can be from a radically new approach to a problem, which results in a new business model or operating procedure. So coming back to this again, we have to invest on research and development, which is going to give us ideas of about how to go forward and what steps we should take, depending on what our final goal is. A whole new range of offerings have been unlocked for utilities with the gradual rise of the connected home, both unlocking demand side response and attracting new players to the energy scenes in the form of telecommunications and technology companies. Electric vehicle cost parity, which is expected between 2022 and 2026, along with other technologies, will cause the traditional roles in the electricity value chain to be eroded, with new opportunities and positions will need to be filled. So let's going forward to my next point is an unrelenting focus on efficiency. So obviously, every business, every power plant, they want more efficient, but you have to bear in mind as we are going more efficient, we have to look after the world as well. We have to have greener world, so less global warming, so less pollution. So in terms of energy efficiency, the drive to do more with less is more important than ever if we are to achieve growth while avoiding the destruction of our planet. Progress on energy efficiency has been striking, yet the potential is still vast. Improvement in energy efficiency since the 1970s in 11 of the IEA member countries saved 1.4 billion tons of oil in 2011, which worth 743 billion USD. Energy efficiency is a major area of investment, with circulating USD about 221 billion USD invested worldwide in 2015, rising 6% what were invested in 2014. In the world of infrastructure, workforce productivity and effective asset maintenance can be combined with lean asset design. All too often, assets are gold-plated and bespoke. By focusing on a standard design, greater efficiency can be built in. And also coming back to our decommissioning of old oil and gas infrastructure is incredibly rising up the boardroom agenda as exposure to significant cost from mature fields and starting to be realized. The cost estimate for decommissioning of the UK Central Continental Shelf basin has been rising steadily, and now it stands at more than 50 billion pounds. So what we can see from here, that as though we need efficient things, we have to think about when we are developing new efficient technology, we have to think about decommissioning our old technology as well at the same time, which is going to cost us money as well. So there is a balance in there. So balance in there and what you want to go. So in this respect, my expertise in my master's, which I did on thermal power, and my specialization was in gas turbine technology. So in any technology, in any power source, the main factor is the thermodynamics. How we can capture the heat and make it to useful work, and that was all my PhD, my undergraduate, my postgraduate was all about. Now coming to the last topic of those five points, the rise of an ever interconnected world. As systems become ever more intelligent, the possibility opens up for the actions of all connected users to be seamlessly integrated to efficiently deliver secure, sustainable, and economic supply of energy. In the US, LO3 LO3 Energy is trialing a system that allows microenergies to sell their power directly to residential consumers. So in here comes the idea of the smart grid. So the whole world can be connected to the smart grid, or maybe a continent can be connected. So wherever there is more demand, the grid can sense itself and send the energy to the demanded area. So that's how the national grid works. So in their future energy scenarios, National Grid predicts that by 2030, the UK could be up to 80% dependent on import for natural gas, which without additional investment in production or import capacity would mean that the UK would be reliant on storage for the periods of peak demand, with more renewable electricity coming online. There will be an increased need to facilitate flows from areas of low demand to areas of high demand with our continental neighbors, like from Europe. Our neighbors in Europe. This will achieve by investing in more interconnectors in order to avoid curtailment, with capacity expected to rise up to 23.25 gigawatt by 2040 from 3.95 gigawatt today. There's a major change. So this was my 5 points that will affect the future commercial and technical involvement for the npower as the leading energy provider in the UK and in the Europe. So with that, I'll conclude my presentation here now. Thank you.